Welcome to The Explainer. Today, we're going to follow the incredible journey of a single drop of water. It's an adventure that connects you, the clouds, the oceans, and pretty much everything in between.
So let's start with an idea that might just blow your mind. That water in your glass? It's not new. Not even close. It has been on an absolutely epic trip for a very, very long time. That's right, millions of years old. And that's because all the water on Earth is part of this huge continuous recycling system called the hydrologic cycle. Okay, let's dive right into it.
To really understand our little droplet's journey, first we need to zoom out and see the world it lives in. And trust me, the scale of this is just massive.
I mean, a quick look at our planet shows it's blue, right? Water is everywhere. About 75% of the Earth's surface is covered by it. You'd think we have an endless supply.
But here's the catch. Of all that water, only a tiny, tiny fraction, we're talking about 3%, is actually fresh water.
So get this, most of our planet's water is either way too salty to drink or it's completely frozen solid in glaciers and icebergs. The fresh, drinkable water that all life depends on, it's incredibly rare, which makes its journey that much more important.
So how does our water droplet even begin its adventure? Well, it starts by defying gravity and going up. Water gets up into the atmosphere in two main ways. The first one's evaporation. The sun's heat hits oceans and lakes and turns that liquid water into a gas that rises up. The second is called transpiration. And this is a really fascinating process that's all about plants.
So check this out. Plants have these tiny little pores on their leaves. When they open up to breathe in carbon dioxide, water vapor actually breathes out. And this isn't just a little bit either. It accounts for a full 10% of all the water vapor in the atmosphere, all from plants just breathing.
Because these two processes are so closely linked, scientists just bundle them together with one big word, evapotranspiration. It's basically the sum total of all the water heading for the sky from both the land and from plants. All right, so our droplet is now an invisible gas, floating high up in the atmosphere with billions of others. So what happens to it up there?
You have definitely seen the next step happen right in front of you. Picture this. It's a hot day, you grab a cold drink from the fridge. After a couple of minutes, the outside of the can is all wet. So where did that water come from? That's condensation. The can isn't leaking. The cold surface just cooled down the invisible water vapor that was already in the air around it, turning it back into liquid. High up in the atmosphere, the very same thing happens, just on a massive scale. And that is how we get clouds.
Our droplet has now officially joined a cloud. But as more and more vapor condenses, that cloud just gets heavier and heavier. And eventually, well, what goes up must come down. This return trip is called precipitation. And depending on the temperature up in the clouds, it can come down as regular old rain, fluffy snow, slippery sleet, or even little balls of ice we call hail.
So our droplet has made it back to Earth, but the journey is not over yet. Now it faces a really important choice, a fork in the road that's going to decide its next adventure. It's either going to become runoff, which is where it just flows along the top of the ground, gets pulled downhill into rivers, and eventually makes its way back to the ocean. Or it'll infiltrate, which means it soaks down deep into the soil. And this infiltration part is so important. It's how we recharge these enormous underground reservoirs of what's called groundwater. This is the hidden water source that fills up the wells that supply fresh, clean drinking water to communities all around the world. So whether it flows over the land or soaks down through it, our droplet eventually gets back to a large body of water, like an ocean or a lake. And it's there that it's ready for the sun's heat to lift it up and start the entire journey all over again. And this right here really shows you how powerful this cycle is. At any given moment, the air above us is holding more fresh water in the form of vapor than all of the planet's rivers put together. It's like a massive, invisible reservoir right over our heads. But this whole thing isn't just about moving water around. The entire process works like a global thermostat. It absorbs heat in warm places and releases it in cool places,
regulating Earth's climate and making our planet livable.
So, the really crucial takeaway is that this ancient, powerful system is also pretty fragile. Our actions, everything from just turning off the tap to preventing pollution in local streams, they have a real impact on the health of this cycle that sustains every single one of us.
It's a journey with no beginning and no end, just constantly moving and changing. And that leaves us with a final thought. This cycle has sustained life for millions of years. So what's our role going to be in protecting its future?